All right, thank you to our hype man Wilder from Amethyst Band. Everybody have a seat, please. We're about to continue with the second half. All right, thank you for being such an awesome audience for the first half. We have 5 more presentations. And if someone can close the door back there, great. Have a seat for the next presenter. Guys, this next presenter, I just want to acknowledge, not only is it his last Brightworks presentation, today's his last day at Brightworks, and tomorrow's his birthday, so can we just give it up for Vihan?
Thank you so much for bringing on my presentation. My name is Vihan, and this is my project, Building a Telescope. So when I was younger, one of my biggest memories was going to an observatory. At the observatory, one of the most magical parts was getting to look through a telescope. When I looked through the telescope, I saw something that looked like this, the moon. This provided a different cosmic perspective for me, which I cannot emphasize. It was just way different than just looking it up or just getting it from someone else. I then realized I could actually get a telescope. When I was thinking about ideas for Space Arc, this idea popped up, so I decided to build a telescope. Today I'm going to walk you through the process of building my telescope. My main inspirations were my curiosity to learn physics, since my other projects were about learning biology and chemistry. I also wanted to learn the laws of light. I also had a huge passion for astronomy, and I love gazing at the stars. I also wanted to learn how these instruments were made and devices. I also wanted to I might want to join an astronomy community in the future, so this would be a perfect place to start. Now that I knew I wanted to build a telescope, I had to decide which type. There are 3 types of telescopes, but I did not include a cast screen telescope, since it was way too complicated to make with my budget. My main telescope types were the refraction telescope and a reflection telescope. I mainly decided on the refraction telescope, which is the one over here, because it only used 2 lenses and it wasn't as complicated. I also could add many more features to it. My main goals were to build a refraction telescope. As a stretch goal, I might be able to try to build a reflection telescope. I also wanted to make my project under $40 to make sure it was affordable. I wanted to learn about physics concepts and optics. I wanted to inspire others to explore the cosmos on their own. First, I started by planning my refraction telescope. I first built a stand for both my lenses to gauge the distance. Afterward, I created a diagram showcasing the telescope and showing how light bends with different thickness lenses. I then, after that, took a picture. As you notice, these images don't look right. That is because they're inverted both ways, left to right, and up and down. Why is this telescope image inverted? Well, my main explanation I managed to get was that, so first, I'm using colors to depict the color rays so it's easier to understand. So the main image actually the main image has the purple light ray on top and the blue light ray on the bottom. But when it gets to the eyepiece lens, which is what the viewer sees, it actually has the blue light ray on top and the purple light ray on the bottom. This means that's going to be inverted. And I also think that this is going to be, since it's 3D, this also works as for the top view, therefore emphasizing why this is going to be inverted both left and right and top to bottom. For the first builds, I was thinking of building a cylinder, but realized why this would be a bad idea, since it would be very hard to fit the eyepiece lens. So I decided to shape it into a cone with the help of Gaver. This was the first build, but then I realized it was kind of pretty annoying to have to hold it and have to position it. So it made me wonder, what could I do to improve it? My next iteration consisted of building a telescope mount for this telescope. I first had to look online for a lot of designs until I eventually was inspired to make this, where I put a bolt outside of the telescope and screwed it in using nuts. I then made the eyepiece lens more adjustable and added a phone stand, but the phone stand was taped on and I realized it could be improved even more. Since it got in the way of blocking the view, I decided to make it attachable by using Velcro. Sadly, now you have to actually hold it, but I think it's still better than the last iteration. For this iteration, I also swapped out the lenses, increasing the magnification from 4 times to 8 times using my magnification calculations. And I also made the eyepiece lens wobble less by adding a cylinder inside to secure it. I actually had some time left over, so I started on my reflection telescope. As you see here, this is the design. A lot of people are wondering what made my telescope mirror special when they first saw my mirror. Well, the thing that's special about this mirror is it's actually a curved mirror instead of your standard mirror. This is because it's curved so that the light can actually bend inside the plane mirror and then the observer can see it. If it were flat, all the light would just bounce back out and you would not really see anything. So this is my build. I first started by spray painting my sheet metal so that no light leaked in. Sadly, some of the spray paint shifted out over time, so there are a few white spots. I also made sure to attach the plane mirror inside by using a wooden dowel cut at a 45-degree angle. I mounted as you see here on the back, that's the plano mirror, which I mounted using makeshift clamps with Velcro to make sure that I do not damage them. I also took a bit of astrophotography. As you see here, I actually had to make sure to flip the images so they look proper. These were taken with the iPhone 11 Pro. I'm pretty sure my telescope can see the moon. I sadly was not able to test this since it's almost impossible to bring this home since it's so big. On Expo, you might be able to see the moon with this, and you also can gaze at the stars. There's a lot of science behind this project, but I'll dive into a few concepts I explored. One of the main things I explored was magnification. In order to get the magnification of a telescope, you have to divide the objective lens focal length by the eyepiece lens focal length. This is mainly how I got to calculate my objective lens, since I was donated this by Rich, and Rich did not exactly tell me the focal length. So I calculated it using this equation. I also learned how reflection is actually calculated. And when reflecting, so this is the library that's pointed over here, as you see, and it makes an incident angle, theta, which is, and then after that you draw a perpendicular line that goes through this, to the point that it intersected. Then after that, in order to calculate the reflected angle, which is alpha, you make sure it's equal to the incident angle it hit the mirror at. This is some of my research, but you can look more at my research during Expo. I'd like to thank Shervan, Gaver, Tito, and Rich for helping me throughout the course of my project. They were very helpful and were very neat. I also would love to thank my classmates for helping me a lot as well, bandmates. At the start of this project, I had many intentions, but this project managed to exceed all of them. I managed to build a reflection telescope and make my refraction telescope very good as well. I also met all my research goals, learning reflection and the laws of refraction. Upon that, it would not fit, but I also learned how light disperses through prisms. I also learned why a telescope image is actually inverted, which I would have never learned without building this project. You can also see my other research I did at Expo. Some building reflections I had were that precision is important. It took me a very long time to build this telescope, since I had to be very careful with the focal lengths. It also took me time to find the dimensions, since I had to precisely measure the telescope stand and keep on adjusting to make sure it has a tight fit. I also had to problem solve to work around setbacks. Since most of the designs I found online for refraction telescopes were tripods, I wanted to actually make this telescope adjustable to make sure you can go up and down to position it right. So I looked more at the reflection telescope designs, which ultimately inspired this design. I also had to find many ways to make the viewing experience better, since my bandmates actually looked through this, and they did have quite a lot of feedback regarding looking through the eyepiece, since it often wobbled a lot inside. I also looked at many forums for inspiration, like I said. Some other takeaways I had were some concepts in applied optics. For example, I also looked through a book about optics, which MC got for me, thank you, Mary Catherine, and I realized that it was very different than what actually happened. I also improved a lot of the shop skills I built upon my time at Brightworks, and used them to solve a lot of problems with my telescope. I also learned there was always room for improvement, because I always kept on improving my project over the course of this project. For example, in the beginning, I actually used to, I improved the phone stand. and a lot of other things. I also learned that persistence helps overcome challenges. I had to persist a lot with building the telescope stand, but this persistence ultimately helped me overcome my telescope stand challenges. Why should you care? Well, building a telescope actually gives you a very different celestial perspective. While, for example, with a telescope, it feels as if the cosmos is just near your home, since you saw it with your very own eyes. Whereas if you look on it at Google, it feels like you're just searching something that is miles away, as if it's out of reach. It's also accessible to anyone, since it's low cost and easy to produce. I built this telescope with a relatively low budget of $40. You can also learn the shop skills required within a week and master them. It's also a pretty hands-on way to learn optics, which really helps with your understanding. It also opens up opportunities to learn more and join local astronomy clubs. For example, another thing that you can do once you've built this is actually take apart a real telescope and improve it. Thank you so much for listening to me. Any questions? Rich?
What can be done to improve the telescope? And you just said that you could take them apart and improve
Yeah, so basically a phone stand is a really big one because no other telescope I found online has a phone stand, so I actually had to build it from scratch without any inspiration. That's one of the main things you can do. You can also replace the eyepiece lens to improve magnification or the objective lens. Other than that, you can also swap out the stand because most telescope stands are not adjustable with height or very hard to adjust. Thank you so much. Oh, Rob?
Two-part question. Have you ever been to an observatory and looked through a real large one? And if not, would you like to go?
I think I did when I was young. I vividly recollect it. No, I actually could not go because of allergies. Okay. But I think I would like to see it now that I'm older because it will be a lot more memorable. Rich?
I remember you working with the sheet metal
Yeah.
crossing, and it was terribly cumbersome, to put it lightly. If you didn't have budgetary constraints, are there any materials that you would love to work with if you remade these?
Of course. I'd love to work with fiberglass because it is a lot more secure. I also might actually buy a cardboard tube next time, but I think that is a bit too basic. PVC would also be a pretty reliable option since I would probably get a big PVC tube to work with.
Got it.
Remy?
In like the starting presentations, you said there was like a third type of telescope that's really complicated. What is it?
Yeah, so it's the Cassegrain telescope. I'm so sorry I did not include a diagram, it just wouldn't fit. So basically, there are two secondary mirrors, which are, I believe, concave. No, planar, yeah, sorry. Concave. And then the light bounces off into a mirror in the middle, which is a convex mirror, and then it bounces out onto the outside through an eyepiece to magnify it. It's pretty cool. Thank you so much.
Hi, I'm building a solar oven. My name is JR. The reason why I picked this project because I did a project like this 2 years ago, and I made that project out of cardboard. So this time I wanted to make it out of wood, which could be a little challenging. For my Space Arc project, I wanted to make a solar oven out of using wood instead for cardboard. I wanted to improve my tools in the shop by using the tools in the shop and research about the solar oven and how the sun reflects off the mirror to make heat. The science behind the solar oven is that how it traps the sunlight into the box. So basically it works by the sunlight reflecting off the mirror, and then it bounces off to another mirror, and then another mirror which traps heat into the cast iron pan, and there's black paper inside, so the black paper absorbs the heat. For my first iteration, I made a cardboard box to get my measurements right, so that all I had to do is measure the wood and cut it with using the tools in the shop. For my final iteration, I made a solar oven out of wood and a mirror. I managed this time by using a calendar making lists and trying to stay on task. I received help from Tito, by him helping me make the solar oven and cutting the pieces. And as you can see here, I labeled like all the different type of materials I used. Through my research, I learned that if you use the cast iron pan, it'll like cook the food and like it'll make it stay hot. I was most surprised to see that solar oven on the left side reached up to 6,332 degrees Fahrenheit, while on the other hand, a regular DIY solar oven can reach up to 700 degrees. I am most proud of being able to use the tools in the shop, like the table saw, the jack saw, and the drill. One of the biggest challenges was having to move the box to follow the sunlight so that it can get hot. But I overcame that challenge by me putting it in the back of the school so that there can be direct sunlight onto the box and it can be able to cook the s'mores. If I had more time, I would improve my project by adding magnifying glass paper or sheets. It's like a regular magnifying glass, but it just looks like thin sheets of paper. One thing I learned about myself is that when there's a challenge on building or angling the mirrors, I will be able to ask for help from like Tito or anyone. In the future, I would like to continue building with wood and using the tools in the shop. At Expo, I would like people to probably try the s'mores if there's any sunlight or like ask me questions. I would like to give a shout out to Eli for helping me make the s'mores and help me make the s'mores and like telling me the temperature so I can jot it down. And Tito, Rich, and Rob, also Shervan for helping me build the box and finding the right angles for the mirrors. Any questions? Gabriel.
You sure this isn't what you were using all my batteries for? Did you get your s'more? Were you able to cook the s'mores finally?
Yeah, we're able to cook the s'more.
Nice.
Rich.
What would you do do you have any thoughts about what you would do to increase the heat inside of your solar oven? Like if you wanted to up your game, which you did, I think last week you incorporated a certain lens. But if you wanted to make it even hotter, do you have any thoughts about what you might do?
Probably add like a lot of black paper and then put like a lot of magnifying glass, like the lenses on and tape it at like the direct sunlight to melt the marshmallow and the chocolate.
Right on.
Will.
How hot was your oven?
The hottest it got was, I think, 145 or something like that. Arson.
Do you think the weather has any effect on where you need to put your box or how hot it gets inside your box?
Yeah, it kind of does. Because if I put it in the front, then like the sun will go that way. So then I have to move it to the back so that the sun can like stay on the solar oven. And sometimes I couldn't do it because it was too cold or just not the right temperature. Wilder, last one. Yeah. All right, next up is Remy.
Hello everyone, my name is Remy. This is my presentation, making a turbojet engine, I'll tell you why it's kind of later in the presentation. So before I tell you how I made this, I want to tell you how does it work, because that's really important. So there are three parts of a jet engine, a turbojet engine, and those three parts are the impeller, or the air intake, where the air gets sucked in. This is what it looks like. The combustion chamber, where all the fire explosion stuff happens. This is usually what it looks like. Sometimes that's complicated, sometimes more complicated, depending on the jet engine. And this is the turbine. So this is where the hot air from the explosions that happen push through here and spin this little axle to spin the compressor. That's kind of what they look like. So yeah, in total, air comes in through the intake. It comes in through here. This compresses the air and feeds it to the combustion chamber, which then in turn combusts, pushes in hot air through the turbine, which in turn spins the air compressor to kind of do a repeating cycle. And you might be thinking, why couldn't we just blow air on a fire and a jet engine? Well, that happens because if you've ever tried to blow fire on a candle or on a low lit campfire, it does not go very well. It blows out. But if you've ever tried to blow it on a almost lit campfire very slowly, it works. That is because fire loves air, but not fast moving air, slow moving air. Yeah. So that is why everything works here, because it turns into just a jet engine instead of just a puny fire, because it's mixed with compressed air. So the air compressor pushes the air molecules together to make it purify more better air to feed to the combustion chamber, which makes it more powerful, basically. So now on to how I make this thing. So I was thinking on using a car turbo for my first air compressor, which is what a lot of people do, because they have one of those impellers inside of them. They do the exact same thing for a car. They bring in air and feed it to the engine to make it more powerful, make the combustion better. But after looking at kind of the price of them, they're a little bit out of my budget. So then Tito, I'm sorry I don't have a photo of you, this does not do you justice, but he showed me, he thought of using a vacuum cleaner, because we had some we were getting rid of. And you might be thinking, why would a vacuum cleaner do anything? Well, a vacuum cleaner, funny enough, has one of these things in it, kind of. It has a impeller inside of it, but instead of getting spinned by turbines and all that cool fun stuff, it gets spinned by a motor that you just plug in. So it's much simpler, but it's also much more cost effective and actually feasible. So yeah, that is the way I did kind of one of the harder parts of my project. But now I need to do the rest of it, which is also hard. So from just like my last project, the Presidio dump is a great place to get a ton of scrap metal, which is what I need for this project. And so I took a few trips there, got a few things I need. Me and Liam did great with our scrap metal. Kind of the three things that I chose were a fire extinguisher, a draft hood from a house, and an empty one of these. This was going to be the outside of my jet engine. This was going to be where I put the air compressor in, and this was going to be the actual combustion chamber. So I cut off the top and drilled some holes. So as you saw in the last combustion chamber, there was a lot of holes, and those are not just randomly placed. There's a very complicated math things for there. So it is 30%, then 20%, then 50%. You drill out that amount of material, but the 30%, 20%, 50% are from the area of the intake. So it's kind of confusing. And that is usually how it works. Mine doesn't look like this, but it looks similar, kind of. And yeah, so I had to drill those holes. That was some hard calculation. Thank you, June, for some help. And then I stuck this in here, and it happened. I didn't do too much. I didn't do very good documentation. So this is why I only have stock photos, kind of. Please load. I have a video kind of explaining my jet engine. Hopefully it plays. Yeah. Play. Hello, future burgers. I am here to tell you about my jet engine. This is how it works. So, first of all, we got the air compressor in here. This is the impeller. This is where all the air gets sucked in and compressed. Then all that air gets funneled through and dropped into here. So this is the two part. This red fire extinguisher, this is the main body. Then this piece, this is the combustion chamber. So this is where all the fire boom boom happens. It's all in there. And then in here is where I stick the fuel tube. So I stick the fuel tube through this hole right here. It goes through this part, the air compressor, and into the back of here. And then when I light it, I turn this fan on, and then turn the fuel on, and then light it over here. Jet engine. So, yeah, that's a little bit of an explanation on how my jet engine works. So hopefully that was kind of informative. It was kind of hard to explain it in the presentation, so I opted on doing a video. Sorry, 1 second. It's not going to the next slide. Shaban, help me. It's not going to the next slide. It's not
Move the cursor back to the presenter view and then click on next. So it's probably you have to move it the other direction.
There we go. Okay, and it worked. And I'm not going to show you an actual video because I want you to come to Expo. So, come to Expo, please. This project exceeded my expectations on how I was going to do it. I didn't really think I was going to be able to finish this, but I'm really happy that I did. And I know you've been waiting for this. It is, I said kind of at the start of my presentation because a turbojet engine, like I was saying, is not what I did. It does not use a motor. It uses turbines to spin the turbo, and so it's not a turbojet engine, but it's pretty close. And I call it a turbojet engine because I think it deserves that. So yeah, I really like this project. I got to be in the shop a lot, do a lot of metalworking, just like last project. Use the welder a little bit, which I was hoping to do. So yeah, it was great. A great thank you to Liam and Tito. Again, I didn't really do good on finding photos, but thank you so much. I could not do this without you guys. Thank you for being in the shop. Yeah, thank you. Any questions? Tito.
Why didn't you show the video of the jet engine work? It's awesome.
I know, but because if you show that, then you might not come to Expo.
Everyone's coming to Expo.
I don't know. Okay, I didn't show it because I wanted to leave suspense. I don't know. True with that.
Have you attached it to a bicycle, and if so, how fast do you?
I have actually attached it to a skateboard, and I have not tested it yet, but I will.
Amazing.
I will. Rich?
Do the parents have insurance for that?
The school hopefully does.
I'm actually changing my question, building off of the prior question. What kind of additional safety protocols were involved?
Yeah, so I made sure to wear a fireproof jacket, and I had a trusted adult light it most of the times. I made sure to stay like far-ish away from it, and I did it in not inside other than the first time. Rob.
Building on that, I was curious as well, when you're cutting through the butane can and the fire extinguisher, how did you empty them? What was your process for making that cutting process safe?
So basically depressurizing them, I punched a small hole through it. I knew it was empty because I could feel it, but just to make sure, punched a small hole through it, or 2 small holes through it, and put them in water overnight just to get all the residual fuel off. And then I cut them open, and I knew there wasn't anything bad in there because I made sure all the fuel residue was out. And for the fire extinguisher, similar thing, but the fire extinguisher actually has a screw-off top, so you can tell that it's not pressurized because you can just screw the top off. And if it is pressurized, you won't be able to. It's just like not possible. One more question.
How is your turbine powered? Does that have to be plugged in?
Yeah, so it has to be plugged in. I mean, technically, I could make it battery powered. It has to be plugged in. Can I do one more? Okay, Vec.
I was gonna say, didn't you get a car turbo from Jiro?
No, he never came. I never saw him. I don't know what happened, but and also even if I did, it was probably too late to do it. Yeah. Okay. Tatsuo and Hudson.
Hello everyone, I'm Tatsuo.
And I'm Hudson Polk. And welcome to our presentation on escape velocity, on the escape velocity presentation we did for Space Arc.
Making this video for our project was really fun, so we're very excited to talk about it with you all, so let's not waste any more time and get right into it. First of all, we need to establish the definition of escape velocity for anybody who doesn't know what it is. Escape velocity is the minimum speed an object needs in order to escape another object's gravitational pull. For example, you would need to go about 25,000 miles per hour in order to escape the gravitational pull of Earth. And now that we got that down, we have to answer a big question about this project in the presentation, and that question is, why? Well, since me and Hudson worked on a project last arc, and I was also looking for someone to work with, we decided to work on another project this arc, simply because I like the project I did with Hudson more than the projects I done individually last year, which I mentioned later. And also, I knew one or two things about escape velocity, but this project helped me learn more about the subject, especially since it seems really interesting to research on.
We were bouncing ideas back and forth between the two of us, and after a while, Tatsuo pitched the idea of doing something related to escape velocity. After a bit more thinking, we came to the conclusion that we should make a video do a video project of like a video style presentation. Since I have a lot of experience with making and editing videos, while Tatsuo was more interested in the opportunity of getting to enhance his skills in those areas, since he hasn't done very much video editing before up to that point.
So, since we decided on our project, we obviously had to work on it, just like everyone else. Like we said, we wanted to make an informational presentation that talks about escape velocity, and we wanted to improve our skills in communication, and just one last thing, also wanted to be able to calmly criticize one another and suggest changes to another's ideas without getting overly emotional. I think he added that, I don't know. Anyway, we managed to get a lot of research done about escape velocity, and we even managed to put direct links to the websites we got for our information document, where we wrote all the facts and stuff to act citation. That wasn't really a first for me though, it's more a first for Hudson. And yeah.
Now for our iterations. Our project started off mostly with research on escape velocity, such as the formula for calculating it, among other things. We also wrote the script for our video, while mainly managing our time through good cooperation, as well as being able to divide and conquer, deciding on who would do what best. Apart from each other, we also received help from our expert in Scotland, who is an astrophysicist named Kyle McLean, who is a great help for figuring out what to prioritize in this assignment.
For our second iteration, we mainly just made the prompts, like you see Hudson doing right here, which were used to visualize certain points we made in our video. The prompts were a model of Pluto, a model of Earth, and a spaceship. We also filmed the actual video by using Hudson's phone in the side building back there because we needed a quiet space to film. Then we edited it all together using iMovie and showed it to various people so we could get feedback on our video to prepare for our final iteration. After we got feedback for our video, we made a few modifications to our video, such as new lines of dialogue, more interactive elements, which is question asked from the audience, sound effects, and video subtitles in multiple languages, which were English and Spanish.
Through our research, we learned that this image is the formula for escape velocity. The gravitational constant, which is represented by g, is the gravitational force between two objects. M is the mass of the attracting object. R represents the distance from the center of the attracting object. We also learned that if an object has an escape velocity greater than the speed of light, it's considered a black hole. We both found that fact pretty interesting, being one of the most surprising things we learned.
And yeah, we were most proud of the use of sound effects in our video presentation, and we didn't really encounter too many challenges, but one of the only ones that we encountered, which was a bit of a minor setback, was Hudson being unable to remember certain lines during filming. And yeah.
We remedied the challenge through persistence as well as trial and error. If we had more time, we would improve our project by possibly getting myself a better lab coat, as well as having better lighting. The lab coat I mentioned is the one I'm wearing in the video, so that's why the idea of getting a better lab coat was brought up.
Overall, I find that I like the results of the assignments I did with Hudson during this year more than last year when I did projects individually, like I said a while ago.
And when it comes to editing, I'm a fast learner. In the future, we would like to continue to improve our skills not only in film editing, but also other skill areas of life. And at Expo, we like people to watch and enjoy our video.
Also, we have a few appreciations. The first one is for Sam and Micheline for approving our project. Second, we'd like to appreciate a friend of Cam's, Kyle McLean, like we mentioned a while back, for being our expert and telling us what to prioritize in our project. And finally, our collaborator Siobhan for establishing our interview and giving us feedback on things like our script and presentation. And thanks for listening to our presentation. Do you have any questions?
You said it was interesting about a black hole. Is that something that you had anticipated, or were you just learning about that as you were going through your project?
Yeah, well, when we were doing the research, that's when we just like stumbled upon that, and we thought it was really interesting, so we included it in the video.
Dad, over there.
How long is your video?
It's
About 5 minutes, right?
not 5 minutes, more
A
like
little less.
like 2.
A little less than that, exactly.
But it's a long video.
It's 2 or 5.
Okay.
Marcello.
Were there any, like, minor miscalculations that led to finding something with an escape velocity over the speed of light?
No, not really. A lot of the, maybe it's actually a better question for Todd's one. As you can see, it's a little bit more research on this specific planets.
Could you repeat the question again?
Did you have any miscalculations that made you think that something had an escape velocity over the speed of light?
No.
Okay,
Last question.
Was there anything in particular from exploration that inspired you to do this project? If not, what was the inspiration other than wanting to work together?
exploration. Nothing's coming to mind right away.
I think we just wanted to learn more about like escape velocity and stuff, because like it has something to do with gravity, which kind of affects the escape velocity of an object, and among other things. We just found that to be really interesting to research about. And yeah, last presentation, Beckett.
Hello, my name is Beckett, and this is my project, The Rocks of the World. And I wanted to do this project because I had seen the other graduation projects people had done to leave something, and I thought it would be fun to try and do something similar. And seeing that I started getting really interested in rocks and geology recently, I decided that doing a project where I get to study them and leave it behind in a website others can look at would be perfect. And this is a photo of me looking at a small rainbow that looked like it was trapped in a rock. For my Space Arc project, I wanted to make a website that I could put multiple essays on that I had written so that others could see them from anywhere, and so I could share it with friends and maybe someday even use it as part of a resume to get into a college or job I wanted. I wanted to improve my researching skills and learn how to make websites, along with learning more about the science behind different rocks like obsidian and how they form, some of their historic uses, and more. For my first iteration, I found a chunk of obsidian on my porch that I suspected is from Mount St. Helens, one of those, to study and write about. And I made a framework for my website with a map and title cards to put things on. For my second iteration, I spent a lot of time reading through different research sources for inspiration and knowledge on what to write my essay on, and then used that knowledge to write an outline. I also took photos of rocks on a pottery reel, which you can see me doing above, so I could put them into my website and make an animation of each rock spinning. For my third iteration, I wrote an essay and finished up the website by removing any bugs I found and putting it in. Throughout my research, I learned that the reason obsidian is so sharp is because of conchoidal fractures, which is when a rock fractures in a smooth, wavy pattern, which you can see here. And they form because of obsidian cooling so fast, it doesn't get a chance to form a crystalline structure. And the reason I found this so interesting was because I had always thought the reason obsidian was so sharp was because of because it had a crystalline structure, so I was really surprised to find out it was the exact opposite. Something I am the most proud of was my website, which I think looks pretty good and works well. One of the biggest challenges I faced was having to rewrite a large amount of my essay twice because some of the info I had based it on was wrong or did not apply to the obsidian I had. I overcame this challenge by working at home a lot in the end and really focusing on getting work done instead of reading. If I had more time, I would improve this project by having started writing the essay sooner rather than later, and having met with Jeremy, who is my geology expert, sooner. Something I found out is that no matter how much I enjoy working on something, if I'm not feeling up for it in the moment, it's really hard for me to get any work done. And in the future, I'd like to continue studying geology and rocks, and at Expo, I'd like people to visit my website and try all the features. I received help from Jeremy with some general questions I had but couldn't find answers to about obsidian, Rich with getting a microscope set up and generally supporting me, Siobhan for helping me with my idea and finding materials I needed, along with introducing me to Jeremy, and both my parents for helping me with my essays and more. I'm really appreciative to all of them for helping me get to where I am in my project. Any questions? Beck?
You said that you struggled with like time management and feeling sometimes you feel like feeling like up to working on stuff. Did you come up with any solutions to that? Do you have any?
An impending sense of doom of not finishing in time. Noah?
Just kind of a two-part question. How many rocks did you write about?
In the beginning, I was planning on writing about 4, but around halfway through, I realized I had nowhere close to the amount of time needed to do that, because I ended up, first off, not managing my time the best, and second, having picked too ambitious of a project to have written about 4 rocks. I think I had like 6 rocks that were a possibility, 4 I decided I wanted to write about, but then ended up having to do just like a really good essay on obsidian. Gaver? Yes.
One of the things I loved about this project when you proposed it was, you had this sort of grandiose scope, but then you were like, I bet I can write about a rock every day. I remember in the conversation, you were like, I bet I can do 1 a day. I can probably do 30 rocks before. I love that it's come down to obsidian. Yeah, I think that's a great evidence of obsession. I guess my question is, of the rocks you didn't get to, which ones are drawing your, which ones are you most curious about?
I think one of them would probably be the geode, which is, if I pull it up quickly, which is, it's this one right here with the rainbow, and also if I pull up this is what the back of it would look like. And something really interesting about that one is I found it in a dumpster bin at Brightworks, and it turns out it's actually Rich's rock that someone that he loaned to Brightworks, and it's somehow gotten thrown away. Dad?
Was any part of it easier?
Maybe making like the framework for the website, just like creating the first few steps. Okay. Rob?
So you said you had worked with a geologist, right? Did you also use an app to see what rocks you might have and to figure out what they were? Or did you do everything through your geologist?
I only met with the geologist Jeremy in the second to last week, maybe third to last. So in the beginning, what I did is I went through a lot of other steps, like finding the Mohs hardness level of the rocks, and using that along with other data I could gather visually to find out what each of the rocks were. And I did not use any site. Rich.
Do you have any conclusions about what the geoworms were? And if you could share what those are to those that are interested.
I don't have any photos of it here, but there are these really interesting like worm-like structures that went through the geode around the edges. And I didn't get around to looking up what they were because I was much more focused on the obsidian because I wanted to get a good essay on that. But they also had this really interesting like ring around them too, kind of, that had maybe what looked like dust particles in it. Thank you.